Okay, so in this video we will discuss double angles, that is your sin 2a and cos 2a. Sin 2a we say is equal to 2 sin a cos a, and cos 2a we can say this is equal to cos squared a minus sin squared a, 2 cos squared a minus 1, or 1 minus 2 sin squared a. Before we can prove or look at the different type of questions, we need to first understand the formula for both sin 2a and cos 2a. So let's start with the sin 2a first. So sin 2a, this is same as sin alpha plus alpha or a plus a, right? We can use the compound angle sin cos cos sin, and we can say sin a cos a plus cos a, and sin a, and this is equal to, as if you can say that this is just like saying AB plus your AB, and then so we can write it as your 2 sin a, or alpha cos a, or alpha, right? So this is to prove or to understand why we are saying that double angle sin 2a is equal to 2 sin a cos a. Now let's look at the other one, the cos 2a one. Okay, now cos 2a we can write it as a compound angle, and that will be your cos alpha plus cos alpha, right? So this is how we can write this cos 2a in form of compound angle. Let's expand this cos alpha minus sin alpha sin alpha, and then this is same as writing your cos a times cos a is your cos squared alpha or cos squared a, minus sin a times sin a is your sin squared a, or alpha. Now we are going to use this to get to the other one, so let's highlight it first. Right, you will find this cos 2a equals to cos squared a minus sin squared a in the formula sheet given like this. Now we are going to use this to find the other two. Let's write this again. cos 2a is equal to cos squared a minus sin squared a. Now we're going to use this. Now before we move on, there is something called your from grade 11 we did the squares identity, so which says the square identity says that sin squared alpha plus cos squared alpha is equal to 1. Now we can make this subject. We can make sin subject, or we can make cos squared alpha a subject. Now we can make sin squared alpha a subject, and we can let this cos squared alpha walk across the equals. So this will become your sin squared alpha is equal to 1 minus your cos squared alpha. Right? So we made sin squared alpha a subject. Now let's come back to our equation here, the question here. So cos squared a minus sin squared a. Now we are going to use this sin squared alpha or a value and substitute in this sin squared a here. So now cos squared alpha will become your minus 1 minus cos squared alpha, and then brackets close. Now we are going to time this minus with the bracket, and we are going to say now this will give us your cos squared alpha minus 1 and plus your cos squared alpha, and this will become your, this is one cos squared alpha, this is another one, so we can add these two and we can say this is 2 cos squared alpha minus 1, and there we go, we found our second formula for the cos 2a, and this is it, this one, 2 cos squared alpha minus 1. So we proved this one. Now let's look at the last one, the last rule. Now again we start with, okay, I'm just gonna write here. So we start with again cos 2a is equal to cos squared alpha minus your sin squared alpha, and then we say that instead of making sin squared alpha the subject in the square identity, now we can make this cos squared alpha a subject, and if we make this cos squared alpha a subject in the identity, we will get 1 minus sin squared x. right? Now we substitute this cos squared alpha is equal to 1 minus sin squared into the thing we are proving, cos 2a. So instead of cos squared alpha, I can write this is equal to 1 minus sin squared alpha minus sin squared alpha. Now the minus sin squared alpha minus sin squared alpha is equal to 1 minus 2 sin squared alpha. So hence we got our third equation for the cos 2a. So this is the third rule. So number one rule was your cos squared a cos 2a is equal to cos squared a minus sine squared a, and then number two rule was 2 cos squared a minus 1, and cos 2a, third rule is cos 2a is equal to 1 minus 2 sin squared a. Okay. Now let's move on to some questions. The question in the exam can come like, use the double angle formula to expand the following. We could use different examples. So let's try. Okay, number one is your sin 2 alpha. So I'm not sure if I could find the grade 12 formula sheet. No, I can't find it. Okay, never mind. We can just, I could remind you the formula and we can carry on without actually looking at the sheet, right? So let's start with sin 2 theta. So sin 2 theta is same as your 2 sin theta cos theta, right? Sin 2a is equal to 2 sin a cos a. So sin 2 theta is equal to 2 sin theta cos theta. If I say instead of 2 theta, I say 50, then this will be 2 sin 25 and cos 25. So please note why we got 25 and 25, right? This is for the double angle 2 theta, sin 2 theta. That's why we say 2 sin theta and cos theta. Now here instead of double angle, they just gave us the value 50, which means we are going to divide this in 2. So this is 2 sin 25 cos 25. That's why I wrote 25 and not 2 sin 50 cos 50. That will be wrong. If I could say, if I give another example, I say sin 4b, right? This will be your sin 2 sin 2b cos. So if this is 4b, this is 2b, from using the formula sin 2a is equal to 2 sin a or cos a. Now this is for the double angle using sin. Now let's look at an example which uses cos. Cos 6b. Another example we could write is your cos 80. Now because cos we have three different rules or three different formulas, we can write cos 2b in, so we can use cos 6b. We can say this will be equal to your cos, using the first rule, right? This is equal to cos squared 3b minus your sin squared 3b. Now another formula or another rule we can use to write this cos 6b, I'm just gonna say, or we can say 1 minus 2 sin squared 3b, or we can use the third rule to write this, that will be a 2 cos squared 3b minus 1. We found all of this using the formula. Let's look at cos 80. Cos 80 degrees, we can say that cos 80 will be your cos squared 40 degrees minus your sin squared 40 degrees. This is using the first rule. Using the second rule, we can say 1 minus 2 sin squared 40 degrees. Using the third rule, we can say, or this is equal to your 2 cos squared 40 degrees minus 1. Now we can write it as a single angle using the sine or cosine as well. So if we have given the expanded form, right, in formula in the exam, and then some part of the question says require us to simplify it into the single angle, or the question itself says write as the sine or cosine of a single angle, then let's look at the example how we can solve those type of questions using the double angles. Okay, we are going to change the color of the pen because this is different type of question altogether, and we can write a question, write as the single sine or cosine of a single angle. Okay, the first example is your let's use the first example. For example, so if I give you 2 sin 3a cos 3a, this is same as the sin 2 3a. So which means we can write this as sin 2 3a, and this is same as your sin 6a. Another example can be your 4 sin y cos y, and this can be split into 2, and then this could, we can say, is your 2 sin y cos y, and this could be your, this 2 can come as it is, and 2 sin y cos y is equal to your sin 2y. So 2 sin y 2y is the double angle for the sin. Now another example can be your cos 2b minus sin 2b. This is the rule number 1 for cos 2a. So this will be equal to your cos 2b, because the angle here we are using is b. Now let's look at another example, that is 1 minus 2 sin squared alpha, and then this is also equals to your, again this is the rule of the cos double angle, the cos 2a double angle, and this will be again equal to, you can say, cos 2a. Another example, a quick example we can use is your 1 minus 2 sin squared 2a. Now this must be very careful with this part, this 2a. This 2a, most of kids get confused here. So this 2a, we can write this as your cos 2 times your 2a, and that is your cos 4a, or you can say cos 4 alpha. Okay, now sin 2p minus cos 2p. Now we can use this one, so we can swap these two around to start writing it as the sine or cosine of a single angle, and so the it will become your minus cos 2p plus now There's a plus sign in between, right? Now we need to factorize, and we can take out minus as a common factor, and then we can factorize. So this will become your minus cos squared p minus your sin squared p. So this is after factorize. Now there is a minus bracket cos squared p minus sin squared p. Now this become your double angle for cos, and this will be your cos minus cos 2p. So these are the different type of exam questions. Now they can ask you to simplify as well in the exam, right? So for example, they can give you something like cos 275 minus your sin 275, right? Cos squared 75 minus sin squared 75, and the question says simplify without using the calculator. So the first step here is to say that this is cos 2 times 75, right? Remember the double angle 2a, cos 2a or cos 2 alpha is equal to, then we have different types. So cos 2 times 75 is equal to your cos 150. Now we reduce this angle, and by reducing we can say cos 180 minus 30 will give you the 150, or another word we can use is we are using the compound rule. So we are using the special angles, and then we can use the rule, and cos 180 minus theta minus 30 will give you your minus cos 30 degrees, because this is in the third quadrant, and in third quadrant 180 minus theta is the cos is negative in the third quadrant. That's why we use this negative sign, and there is your cos 30 degrees. Now negative cos 30 value is your root 3 over 2. So this is your final answer for this type of question. Okay, so this was all for the double angles. I hope you understand and you like today's lesson. Please let me know if you have any questions or any confusion, and we can go over it again. Thank you.